Welcome students. We are going to study about the chapter polynomials, and these are the points which we are going to cover through this video. So let us start with our first topic, that what is a polynomial.
A polynomial is an algebraic expression of finite length made up of variables and constants by using only the operation of addition, subtraction, and multiplication and non-negative whole number exponents. For example, x squared minus 5x plus 3 is a polynomial. The highest power of the variable in a polynomial is called the degree of the polynomial. Let's take a look at the polynomial 6 minus 3y to the power 5 plus y cube minus 2y to the power 6. Here the highest power of the variable is 6. Therefore, the degree of the polynomial is 6. A polynomial is classified according to its degree. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. A polynomial is written in the standard form by writing the polynomial in decreasing order of its exponents. An example of a standard form of a polynomial is ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Let's test your understanding of what you have learnt so far. In your notebook, write each of these polynomials in the standard form and identify its degree. When you are done, click each problem to view the solution and check your answers against it. Now identify the kind of polynomials given here and provide reasons for your answer. When you are done, click each problem to view the solution and check your answers against it. Let p of x be any polynomial of degree 1 and let a be any real number. If p of x is divided by the linear polynomial x minus a, the remainder is p of a. By remainder theorem, on dividing p of x is equal to x squared minus 1 by x plus 1, the remainder will be p of minus 1. Since p of minus 1 is equal to 0, the remainder is 0. Suppose p of x is a polynomial of degree n, where n is greater than 1, and a is any real number. Then x minus a is a factor of p of x, if p of a is equal to 0. P of a is equal to 0 if x minus a is a factor of p of x. To use factor theorem for polynomials with degree 2 and 3, split the middle term. Have you ever wondered why the zeros of a polynomial are so important? An understanding of the geometrical representations of polynomials and the geometrical meaning of their zeros will answer this question. Let's start with the definition of zero of a polynomial. A zero of a polynomial is that value of x at which the polynomial p of x is equal to 0. If p of x is a polynomial and a is a real number such that p of a is equal to 0, then the following statements are equivalent. A is a zero of p of x. A is a solution of the polynomial equation p of x is equal to 0. And x minus a is a factor of the polynomial p of x. The x-intercept is that value of x where the graph touches or crosses the x-axis. At the x-intercept, y is equal to p of x is equal to 0. A polynomial function of degree n has at most n zeros. Let's look at the graph of a constant function. F of x is equal to 3 is a constant function with degree is equal to 0. What do you think the graph is like? The graph is a straight line that does not intersect the x-axis at any point. Hence, it has 0 x-intercepts. Now, what do you think the graph will be like for a linear polynomial of degree 1? Suppose f of x is equal to x plus 2. Look at the graph. You can see that it intersects the x-axis at only one point, minus 2, 0. Hence, its x-intercept at that point is minus 2. In other words, at the point minus 2, 0, y is equal to f of x is equal to 0. Thus, the number of zeros is 1 for a linear polynomial of degree 1. What is the geometric meaning of 0 for a linear polynomial? The graph of the linear polynomial f of x is equal to ax plus b, where a is not equal to 0, is a straight line. It intersects the x-axis at exactly one point minus b by a, 0. Therefore, the linear polynomial has only one zero, which is the x-coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. What do you think are the zeros of the following quadratic polynomials? P of x is equal to x squared plus 2x minus 15. When we solve P of x is equal to x squared plus 2x minus 15, we get x plus 5 multiplied by x minus 3. This implies that P of x is equal to 0 when x is equal to minus 5 and x is equal to 3. Let us see the graph of P of x is equal to x squared plus 2x minus 15. What are the x-intercepts of the graph? You can see that y is equal to 0 at 2 points, minus 5, 0 and 3, 0. Therefore, the x-intercepts are minus 5, 0 and 3, 0. Let us see another graph of a quadratic polynomial. f of x is equal to x squared plus 3x plus 2 is a quadratic polynomial of degree 2. f of x is equal to x plus 1 multiplied by x plus 2. This implies that f of x is equal to 0 when x is equal to minus 1 and x is equal to minus 2. Let us see the graph of the polynomial. It meets the x-axis at 2 points, minus 2, 0 and minus 1, 0. Hence, the x-intercepts are minus 2 and minus 1. Thus, the maximum number of zeros for a quadratic polynomial of degree 2 is 2. Therefore, we can conclude that the x-intercepts in the graph are the zeros of the polynomial. Now, let's look at a cubic polynomial. f of x is equal to y is equal to x cubed minus 4x. This is a polynomial of degree 3. So, what will the graph be like and what are the maximum zeros possible? Let's take a look at the graph. There are 3 x-intercepts. Therefore, the maximum zeros for a cubic polynomial of degree 3 is 3. Can you find all the zeros and turning points of the graph of f of x is equal to x to the power 4 minus x cubed minus 2x squared? When we factor the polynomial, we get f of x is equal to x to the power of 4 minus x cubed minus 2x squared. This is equal to x squared multiplied by x plus 1 multiplied by x minus 2. The zeros of this polynomial are x is equal to minus 1, x is equal to 0, and x is equal to 2. These correspond to the x-intercepts minus 1, 0, 0, 0, and 2, 0. The graph shows that there are 3 turning points. Since the degree is 4, this is the maximum number possible. A polynomial function graph consists of a series of hills and valleys called turning points. The maximum number of turning points is 1 less than the degree of the polynomial. For example, if the degree of the polynomial is 3, the graph would have a maximum of 2 turning points. In a polynomial function, 0 is an x value for which y is equal to 0. It is the value at which the graph touches or cuts the x-axis. In a polynomial, the maximum number of zeros is equal to its degree. The quadratic polynomial f of x is equal to ax squared plus bx plus c can have 3 cases for the graphs. Case 1. There are 2 zeros where the graph cuts x-axis at 2 distinct points. Case 2. There is 1 0 where the graph cuts x-axis at exactly 1 point. Case 3. There are no zeros when the graph does not cut x-axis at all.